Chapter 7, Section 1 is about scientific notation. Scientific notation is used to write very large or very small numbers. So used to write, I'm just going to say large or small numbers. If you have a positive integer exponent, let's say 10 to the second power, that would have 2 zeros after it. If you had 10 to the fourth power, it would have 4 zeros after it. So the general rule is, whatever the exponent is how many zeros you have. So the exponent is how many zeros you have. Negative exponents, if we have 10 to the negative 2, it would be 0.01. If you had 10 to the negative fourth, it would be 0.0001. So in this case, the exponent tells you how many places you have. The exponent tells you how many decimal places you have. So the exponent tells you how many decimal places you have. And using those ideas on the first 4 examples, number 1 is 10,000. We are asked to write these as a power of 10. There is 1, 2, 3, 4 zeros, so that would be 10 to the fourth. Number 2, there are 1, 2 zeros, so that would be 10 to the second. Number 3, there are 1, 2, 3 places. That 1 is in the third place, so that would be 10 to the negative third. And then this one, there is 1 decimal place, so that would be 10 to the negative first. Now when we write these next examples, 5 through 11, in scientific notation, we need 2 things. We need a number between 1 and 10 times 10 to some power. So they're all going to look like that. We just need to figure out the number between 1 and 10 to what power. Well, right here, if we look at this, we could put a decimal between the 7 and the 6, and we would have 9.76. That's a number between 1 and 10. And if we have that, then our decimal point has to move over 1, 2, 3, 4, 5, 6, 7 places. So that would be 9.76 times 10 to the 7th. We're going to go to this example 9 next. A number between 1 and 9 would be 7.29. And then we need 10 to some power. And if we move this over 1, 2, 3, 4, 5, 6, 7, 8, that would be 7.29 times 10 to the 8th. Next, we're going to go to number 11. We need to somehow make this number between 1 and 10. And we're going to put our decimal point right there between the 3 and the 1. So we would have 3.12 times 10 to some power. And we have to move our decimal point over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that would be 3.12 times 10 to the 11th. And now back up to question 7. Making this a number between 1 and 10, we would put our decimal point between the 4 and the 5, 4.578. And if the decimal point was right there, it would have to move over 1, 2, 3, 4 places. So that would be times 10 to the 4th. And you'll notice we just did our 4 large numbers. Now we're going to look at our 3 small numbers. Same idea. We need a number between 1 and 10. So we would put our decimal point between the 5 and the 4. And then if the decimal point was right there, we moved it 1 to the left. Since we're moving it to the left, we have a negative. And since we moved it 1 place, it would be 10 to the negative 1. Number 8, making this a number between 1 and 10, would be 1.95 times 10 to some power. And if that decimal point was right here, we would move it back 1, 2, 3 spaces. So that would be times 10 to the negative 3rd. 1.95 times 10 to the negative 3rd. Number 10, writing this number in scientific notation, we need a number between 1 and 10. So that would be 4.56. The decimal point would be right there between the 4 and the 5. And we have to move that decimal point over 1, 2, 3, 4, 5, 6 spaces. Since it's to the left, it's a negative. And we moved it over 6 spaces, so that would be 10 to the negative 6. The next 4 examples are not in scientific notation, but we can still find the value of these. If we have 0.00195 times 10 to the negative 3rd, that means we want to move this decimal point 3 places to the left. And if we do that, we have 0.00000, 1, 2, 3, 4, 5 zeros, and then a 195. Number 13, we have 853.4 times 10 to the 5th. That means we are going to move our decimal point 5 places to the right. It's positive this time, so we move it to the right. 1, 2, 3, 4, 5. And we put those zeros in. We should probably put a couple commas in. And that is our new number. 14, we have 0.163 times 10 to the negative 2. It's a negative, so we move our decimal point 2 places to the left. And we have 0.00163. And number 15, again, we have a negative, so we're going to move our decimal point 6 spaces to the left. And we will have 0.00000. 1, 2, we have 5 zeros. 1, 2, 5. Actually, I think we only have 4 zeros. And then 1, 2, 5. And the last example, Saturn has a diameter of 1.2 times 10 to the 5th kilometers. Writing that in standard form, we have to move this decimal point over 5 spaces. So this will be 1, 2, and then we fill in the remaining with zeros. And then writing this number in scientific notation, we would have 1.427. Put the decimal point between the 1 and the 4. And then we move the decimal point over 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1.427 times 10 to the 9th.